Okay, so this is a ball at rest. Everybody see this?
That's like creepy.
Okay, here's a ball rolling slowly. Here's a ball rolling fast. Slowly, fast. Okay, again, slowly, fast. Slowly, fast. Tell your neighbor what you see and why you see it.
Yeah, it looks like a stop motion.
You'll see more. You'll see more.
I think it's made my vision work. Hey, don't you work lag?
Dude, I like it. When you go fast, you get a better angle.
Okay, here come the lights. Okay. Hopefully your conversation has sounded a little something like this. When it's going slow, that means the image of the ball is close together. Okay, because it's clicking at a constant rate, so it doesn't cover that much distance in that amount of time. Versus when it's going fast, it's able to cover a larger distance, so you see it boom, boom, in that same amount of time. Good with that? So this is another way to describe motion. Maybe when your kids are taking physics, we'll have worksheets that have animated pictures on them, but right now we're trying to capture motion, describe motion, depict motion with still photographs. Okay? So here we go. Strobe light diagrams. So here, this is going across, going to the right. We're going to say that's the positive direction. So I want you to figure out what the correct position versus time graph is going to be. Thumbs up when you have something. Tell your neighbor.
That's right.
Okay. Everybody go with B? Okay. It's moving at a constant rate in a positive direction. Constant slope has a positive slope. Okay. Thumbs up when you have a guess. Tell your neighbor what you think.
I thought it was the opposite.
Same, but I get that.
Okay. Correct answer is. Okay. Here we go. Ready? Correct answer is B. All right. Now, I'm going to describe why B is right and why C is wrong in terms of C is the popular wrong answer. Okay. So B is correct because here this depicts moving fast. You're covering a large distance in this time interval. Okay. Here, you're moving slow because it only covers this distance in that time interval. Okay, so steep slope corresponds with fast in the negative direction, shallow slope in the negative direction corresponds with slow. Okay, if that makes sense to you and you're good with that, close your ears. I'm going to describe why C is wrong. So if you're tempted to do C, here's why I think you said C, and I want to like derail that. But if you're good with B and that made sense to you and you're fine with that, just close your ears. Okay. The popular misconception with it, or like wrong interpretation of this, is like, oh, look at this. Okay. That's not equal time intervals. Okay. It's not going slow, fast. It's going fast, which is steep slope, to slow. Okay. And unplug your ears. Okay. Try that one. Tell your neighbor.
Oh, right, yeah, so, yeah, no, it's
Slow, fast, slow. Oh, that makes sense.
no, it can't be D. Because D, because it gets slow again. It means it starts slow. Okay, I see. So that's why, yeah, no, because,
How we doing? Correct answer is? Correct answer is D, dangerous dinosaurs. Slow, fast, steep, slow. Good, shallow. All going in the positive direction. Okay. Tell your neighbor. Correct answer is? Everybody go with B? Okay. So here's how you interpret this. This is the same diagram, just I've color coded it depending on where the ball is located at certain time intervals or at certain clock readings. Thumbs up when you have something. Tell your neighbor.
It's like 0.055. Not like dots.
Correct answer is?
B.
Everybody goes B. Okay. At the zero time reading, they're together. At the purple time reading at 5, they're together. Okay, this is the answer to the previous question. Tell your neighbor how this graph verifies that. Okay. Is everybody good with they have the same intersections here and here? They're same location at 0 and 5. Good? Okay. Velocity versus time graph. Tell your neighbor.
Hey, we already all know. There's no need to play. Nope. We all got 15 minutes.
I know, like I get kind of tripped up with it.
Not necessarily.
Oh.
Not necessarily. Correct answer is A. You start slow and speed up in the negative direction, so you start close to 0 and move away from 0 velocity. Good? Next question. Thumbs up when you have something. Tell your neighbor. Correct answer is? Correct answer is C. Crazy cats. Okay? You're always moving in the positive direction. You're going slow, so you're close to 0. Going fast, you're away from 0. Slow again, closer to 0. All in the positive direction. You're all above the x-axis. Good? Have a conversation.
It's D. Bro, it's not D, bro. It's A, dude. It's D. That's D because they never intersect at the end. I promise you. I promise you. The only one that does it's D. No, it's the A in it. Okay, it doesn't matter though. It doesn't matter because it's not a position graph. Even if they intersect at the end, it doesn't matter. It's D. It's velocity. I know.
Correct answer is?
D.
Oh, buddy. Find someone you disagree with and convince them that you're right and they're wrong.
Wait, what do you think it is?
Yeah, I agree. I'll go there. That was my first thought.
We can mention. It's not position graph. It's a velocity graph. Yeah, we never mind. Just go in one direction.
I think so.
Well, they do.
No,
that's bad. It's
Okay. Here's my recommendation. Forget orange and just think of the blue. What is the blue going to look like on a velocity versus time graph? It's going to look like a horizontal line. Yes? Yeah. Okay. And forget the blue, think of the orange. What is the orange going to look like on a velocity versus time graph? So what are those both doing? A. A is the right answer. Okay. How are we doing? Is that
So since it's not position versus time, they don't have to be at the end.
right?
So it doesn't matter. Yeah.
Okay. So okay, before you talk, see if this graph corresponds to what you just answered for this question. See if A matches, agrees with your conclusion. Tell your neighbor. Tell them why you think so. Tell them why you think so.
You're right, though. I don't like the way you describe it.
Oh, I use the graph. I use my middle distance. But if we don't see the graph, yo, my calculator, bro.
Yeah, I'm not gonna lie. You can take that, Mr. Smiley.
My calculator fell in my pocket. Use my advanced calculator. Come on.
It's a really advanced calculator.
Come on. No, Mr. Smiley, you're not like this. Come on, Mr. Smiley.
I am like,
Oh my God. Dude, I was in my head in my pocket.
it was in your pocket. Put it in your bag.
Go, Mr. Smiley.
Put
in
it,
your locker.
put it in your bag.
Car. Well, he doesn't have a car, so.
All right. Correct answer is D. They are from 2 to 3. They cover the same distance. Does that make sense? And do you see how it matches? They have the same velocity at that moment in time. Okay. Last question. How does this graph, which is correct, verify? How's that verified with this answer here? Okay. Go ahead and tell your neighbor.
I want you to tell your other neighbors.
Let's look at all the
For the sake of time, what on a position versus time graph tells you velocity? Slope. Where is the slope the same? This is a constant slope. Is it right here? Is it right here? What about like somewhere in here has the same slope? Okay. We got a lab quiz on Monday. Review worksheet due on Tuesday.
Yeah. No, it's right. Yeah, when the top one's going 1 to 2, the bottom one's going 2 to 3.
Have a great weekend.